Hi guys, welcome to my YouTube channel. I am Swapnil Mukherjee, and let me tell you that this is my first YouTube video. So today I'm gonna explain projectile motion, which is a part of kinematics, which we usually study in class 11th within. So projectile motion is an example of two-dimensional motion, okay, involving the x and the y axis. And a common example, suppose we have a ball, maybe a cricket ball, and we are throwing it in a direction uh, having certain angle with the angle theta with the x-axis. Okay, we are throwing the ball at a direction such that it is making an angle theta with the x-axis, right? So it will follow a path something like this. Okay, something like this. Now let's try to make it a bit nice. Yeah, so it follows a path like this, right? The ball goes like this and like this. So suppose we have thrown the ball with a velocity u. Okay, so as we have studied in vectors, we can divide a vector into components, right? So when we are throwing the ball with a velocity u, we can divide it, break it into components. So along the x-axis we have u cos theta, and along the y-axis we obviously have u sin theta, right? So let me introduce you to certain important points. This particular distance is known as the range. Okay, range. And this height is the maximum height h. Okay. Now projectile motion, as you can see from the diagram, it is following a parabolic path. Okay, parabolic path is what it follows. Now, what will be your first task is to find the equation of the trajectory. Right. So, how to find the equation of the trajectory? For this, attention towards the x-axis. So, along the x-axis, we see that suppose at a time t, okay, at any time t, at time t, the distance traversed along the x-axis, which is x, is equal to u cos theta into t. Let it be equation 1. And let's see t equal to x by u cos theta. Okay, this is equation 1. Now we will be moving our attention towards the y-axis, right? So at any time t, uh, we will be having y is equal to u. So before this, let me tell you, I hope you're familiar with the equation of the kinematics, which is s is equal to ut plus minus half at square. So it's a pretty common equation. I hope everyone is familiar with it. So the similar thing we are applying it here. Here the s is y. Okay. The u, that is the velocity, initial velocity, is u sine theta into t minus. Now why minus? Because please have a look. The initial velocity is upwards, that is towards the positive y direction, and the acceleration, that is g, is towards downward direction. Therefore, we have minus sign here, right? Then we have half gt square. Now we are going to substitute the value of t from equation 1. So let's have a look. Y is equal to u sine theta into t, which is x upon u cos theta minus half g t square, which is x by u cos theta whole square, which is, we see that u and u gets cancelled out. So y is equal to x sine by cos, we know it's tan theta, minus half g x square upon u square cos square theta. Okay, so this is, one second, so this is the equation of the trajectory of projectile motion. Let me repeat it once more. Y equal to x tan theta minus gx square by 2 u square cos square theta. This is the equation of trajectory of the projectile motion. So that's all for now. I hope you liked the video. Please do like, share and subscribe. Thank you.